course.
Hi, everyone. Thanks for staying here. I know it's not easy to stay until the end of the conference, so I really appreciate that you made the effort to stay here. It's an honor for me to be here. We actually have an office in Stockholm. I'm personally based in Helsinki. I'm technical evangelist with AWS. It means I travel the world and talk with amazing customers. I think I have one of the best jobs in the world because I got to work with some of the largest and most amazing companies in the world, gaming, enterprise, you name it. And today, this talk is about trying to give you a sense of some of the things I've learned as a customer. I started using AWS in 2007, and I've never stopped using, so it gives me about 10 years of AWS experience. So yeah, this talk is something that is built from my heart to you, and hopefully you can take some of it home and think about it, or maybe improve actually what you're doing currently on the net. When we talk about scaling, I think a lot of people either start to hold their heads and don't want to get into the conversation, or they think it's going to be very difficult. And indeed, it is a long journey, right? But I always like to refer to the ants. Ants do amazing journey, carrying all this back to the nest. So if they can do it, any one of us should be able to do that. It's just a matter of being very well organized, like they are. So scaling is about a lot of stuff, right? And you can talk about scaling in an architecture way, but I think scaling touches a lot more than just architecture. And one big part of scaling is actually cultural. And I'm going to talk about those as well, how culture allows you to scale your application. It's also about operations, right? If your operation does not scale, your application is not going to scale, your API is not going to scale. So that's something that we need to think of when you want to scale your application. But it's also an architect work. I myself joined AWS as a solutions architect, and I've been working in the Nordics with some of the largest game companies that you know. So, I can tell that all those three components are actually very, very much important, right? And if you want to talk about scaling, please at least have an idea about those three. Don't leave one or the other away. So let's talk about cultural needs first, because I think we need to get this out of the way to talk about the meat and the architecture. But for me, this is probably the most important thing. When we go to customers and customers ask us, all right, guys, how do we scale? The first question is not, how do you run your application, or what is it that you're running, is how is organization organized, right? What do you do? Who are you as an organization, right? And you can think that, I don't know, probably a lot of you have heard this Conways Law. I think it's a beautiful interpretation of the interaction between an organization structure and how your software is going to be. Basically, what it says is your software is going to be a reflection of how your organization is set up and designed and architected. Simply because when you release software, you have to communicate a lot. You have to organize yourself as a company. And if you don't have the same bits and pieces that you need for your software as an organization, it's not going to work. One very good example that I love to take of is code quality. How many of you have heard of the broken window theory? Right. Again, I love this because in my previous role, they called me the code quality bitch, right? And actually, I was really proud of that because of the broken window theory. Let me explain you what it means for me. Is that if you have a broken window on the building, other people are most likely, or they will feel that they are fine throwing another stone to another window and break another window, right? So basically what it says is if you leave the initial first broken window, the rest of the building is going to be shattered in a matter of days, right? Whereas if you replace it very fast, nothing is going to happen. People are going to think twice before trying to break a window. And with code quality, I feel it's exactly the same. Sorry. Just to talk a little bit, because I was here in the previous session about documentation, I think I just would like to put my comment on it. Very few people see documentation as actually a mean for the organization that develops the API to know what it does. A lot of people refer documentation as for the customers. Let me tell you how Amazon does it, or AWS, we do it. We write the press release, the FAQ, and the documentation before writing any code. And this is not for the customers to know what we are building, it's for us to know what we are building, right? And for the team to not have to ask questions in the next 6 months about what we are building. Basically, what we think is, if you make the initial decision before, you're most likely to have an MVP product in a couple of months. If you don't write the FAQ, the documentation and the press release, basically the team will have a different idea of what we're trying to build, and then you're gonna have to resolve those conflicts, right? So I think documentation as this part of this aspect as well that I think is very important to think about. There's lots of things that I think are important, but in my opinion, these are those points are the most important. At Amazon as well, what I want to talk about is how, we were a monolith application in 2001. From 1994 to 2001, basically, we were victim of our own success and growth. We just built one big monolith. And as a company that prides itself to be the most customer-focused company in the world, we actually were waiting most of the time to deliver code to the production, right? So we had to make big organization change. One was split the software into the big monolith software into microservices, organization, but also culturally split our organization into what we call two pizza teams. And we had a discussion during lunch about what's a two pizza team at Amazon. It's a team that is responsible for writing the FAQ, press release, documentation, writing the code, deploying the code, maintaining the code, and be on call. And those teams are 10 to 15 people, right? And across the entire AWS and Amazon, there's thousands of those, right? So we outsource the thinking to those two pizza teams simply because we want to go fast, right? So basically, our organization is microservices, and our software is microservices. And this is where we have a good marriage, right? I could talk about this for hours. Let me move on a little bit. It's just to give you a little bit thoughts of what's happening out there. Another thing that is super important, and you've mentioned that during this conference, is security. For us, is job zero. But I wanted to give you my opinion of it as a customer. So in my previous life, we were a team of 5, 6, 7 people trying to go fast, release fast software. And at some point, we spent literally a couple of months just trying to figure out the right security models, how it would work. What I always say is, we were trying to pretend we actually were security experts, where we had no goddamn clue what we were trying to build. So basically, we wasted 2 months of our resources to try to do security. What we should have done is recognize our stupidity and hire an expert. So this is what I recommend you to do. And the second is, if you have the possibility, use a service for that. At AWS, we have a service like Cognito, and as a customer, I realized that service way too far away, long in the process of writing application, and in 2 lines of code, it saves us 2 or 3 months of work, right? So basically, we could integrate the entire security model in Cognito, and we could then finally work on our application and make it good for our business. We didn't have to become security experts. So this is what I'm thinking. Really, a lot of startups start small. Do what you're good at, yeah. And that comes also with hiring the right people. I think this is the single most important thing I've learned in 10 years of trying to hiring engineers and scale application. And I'm talking hiring and scaling is totally related. And we've all heard that saying that a good developer is great, but a great developer is way much better than a good developer by tenfold. And this is true from my experience. A great developer will care deeply about what he's writing and also care about the customers. I work with people that cared a lot about customers, but not much about the code, and vice versa. These don't work, right? So, I mean, if you're planning to scale your application, make sure you have the right people there because it's super important. And the right people will also make your culture great. Let's talk about the second thing, operational needs. And this comes, of course, with the right people as well. The operational needs, I love that meme is because this is really basically related to culture. If your people care deeply about code and about your company, they will not say this kind of stuff. It's not my problem anymore. This is the ops team problem, right? I love working with developers that actually chipped in. And when things go bad, actually are the one who are pulling the fire out. And this is also what we do at Amazon with our two pizza teams is we do write the code, we deploy it in production, we maintain it, and we actually try to remove the fire when shit hits the fan. So this is very important. A couple of things that I've learned, at least in those 10 years, is infrastructure as code is, well, I would say probably the most innovative things that has happened in the last 10 years. The fact that you actually can treat your infrastructure the same way as you write code is simply beautiful. You can code your security, version control it. It means that it just doesn't only mean that you can code it, but it means that you can make sure there's less configurations drift. You can make sure that you can replicate this environment if something would go wrong. You can make sure that your test, staging, and prod environment are actually exactly the same. And this is something that is really important. If you are about to scale an application, you don't want to spend time trying to figure out what's the difference between my test and staging environment and say, well, but things worked in test and they don't work in stage. Yeah, most likely there's a developer on Friday evening that had to make a code very hot fix, open a port SSH on an instance, forget to close it, and then on Monday realized that actually the database was accessible to the world from the entire weekend, right? So these kind of things, are crazy, but they happen. And infrastructure as code, especially treat this as a configuration drift. Safety is great, especially for scaling. Continuous integration delivery, again, this is a no-brainer, simply because you want to do this repeatedly and you don't want to spend human time at testing, building, deploying. It should happen as it goes. Just to give you some data, between 2001 and 2009 at Amazon, when we did this big shift of splitting our organization into microservice, both software and people, we experienced, and actually we built a lot of tools. So we spend a lot of time building tools to deploy fast, especially to have this feedback loop between things in production and back, having customer feedback fast to the team so we could iterate fast. So we realized in 2009 that actually frequent deployment also enabled us to stay much more on time. Right? Uptime increased dramatically. We had a lot less outage, and those are quite numbers that speak for themselves. Another thing that I think is really important is realize that deployments are actually a metric of innovation as well. And in 2014, when all our changes were done, we were hitting 50 million deployments a year at Amazon, right? So it's 3 per second if you think about it. So it's quite possible for anyone to implement that. Monitor everything is also a no-brainer. As I say, when I was a customer, the biggest problem we had was when we didn't monitor how things were happening, monitoring the database. What kind of queries do we have in the database? Why is the database taking so much time? Monitor what type of query you have. How many updates query do you have? How many lock queries do you have? All this kind of stuff. Especially set up alarms. Monitoring is great. If you don't have alarms to tell you that something is out, it's useless. So all this kind of stuff are very important. Let's talk about architectural need now, because I think a lot of people expect this talk to go into architecture. And here I'm going to talk about some of the things customers are doing and work very well. Of course, scalability, you want to add availability and reliability and redundancy in that. So just to give you an idea a little bit, we have currently at AWS 16 regions. What I want to talk is not the number of regions, is our region is constructed, because this is how we define highly available application. And the region for us is a set of availability zones, right? And availability zones are geographically separated. They have different grid, electricity grid. They have different earthquake plans, different fire plans, so that if something was to happen in one particular availability zone, the other one would be able to recover. And this has become basically our unit of availability, right? So applications that you want to scale need to be highly available, and you need to have those running across 3 availability zones in that kind of way. Don't take this as an application architecture that you can scale to 10 millions, but what I'm going to do, I'm going to take that design for the rest of this talk and improve it to grow it. But basically what you can see here is I have web instances behind load balancers, and those are split across 2 AZs. So that's the most simple way to stay available. If my region on the left would go down, the load balancer would detect that the health check is wrong and then move the traffic to the other availability, and then you would have a failover from the master to the standby. So this is quite straightforward. It doesn't happen without downtime. This is between 30 seconds, 60 second downtime, but nonetheless is the first thing you can do for having highly available content. You can notice as well, I have an S3 bucket outside of my regions, because this is where I put like all my pictures, content, the GS files, so I don't want to serve content, static content from my web instances, right? My web instances need to return business information, not content. Right? Content needs to be served from the CDN, for example. Another thing which I found out is a big problem is people want to do microservices, but then they have state in their application. And if you do that and your application goes down, basically you lose information, right? So having state out of your application, especially the web instance in that case, allows you to actually have very dynamic application. You can kill them, restart them on demand as fast as you want, because the elastic cache, or basically the cache outside, store information, especially stateless. Make your application stateless, right? And the kind of information that you want to store in the cache is transient information, like a session ID, right? My session ID or my host token might change every 30 minutes, this kind of stuff, or my session change much often. So you want my web instance to basically, if it dies, not the other one would pick up let's say the information from the cache, so you wouldn't have to relog and all this kind of stuff. Those are basic principles of how, for example, we do the shopping carts, all this kind of stuff. Because you might have a shopping cart for a duration of 1 week or a month, and you don't want to have to redo the shopping cart every time, right? This kind of stuff. Of course, an important thing once you have this is autoscaling. And if you've analyzed a little bit traffic, and if your application is more regional than global, you have seen this kind of traffic shape on your API, right? So basically, people sleep at night, so they don't use your service. That means that you also want your application to sleep at night and not be used, right? And especially, you want that if your application has a sudden need for more resources on the infrastructure, it can scale. And this is where autoscaling comes into the picture, and this is a primary reason to have autoscaling groups. So this is a very simple representation of how to simply use an autoscaling group. You can have multiple of those. In fact, customers doing very advanced autoscaling group can have autoscaling groups for spot instance, for other for CPU-bound application, memory-bound applications, so that actually they can scale on the metrics that they need for the particular current need. Yeah. A very important thing is asynchronous patterns as well. And this is where message passing comes into the picture. This is, for me, one of the most beautiful way to scale your API. A lot of the APIs that we see out there don't need to return exactly what is asked. Actually, the client can just wait 30 seconds, sometimes more, or 10 seconds or more. What you want is have a fast response so that your client doesn't just wait in the loop. So if you can return fast the information to the customer and then process that information later, it allows you to do a lot more with your API, right? So asynchronous architecture works like this. Basically, your web instance get a request from your API and then puts that particular job into a queue and then returns, right? So then my job is passed to workers, and basically what they do is they store information into the cache, which then I can access or send a notification to my end users that something has been received, and then you can retrieve that. A lot of the applications that you're using today, like Instagram, Facebook, or very demanding application, Amazon, they all are built like this. So basically, there's no one UI. There's a UI that makes you feel you're real time, but under the hood, it's all asynchronous because things break all the time at that scale, and you need to recover, right? So if you have an asynchronous pattern that scale, your UI basically will not notice that, and you can redo things behind without having the user having a bad experience. And then you end up in architectures like this, where you have highly decoupled infrastructure. So we are across availability zone, decoupled between my API and the workers that do the job. So you can have quite advanced architectures like this. Those are architectures that customers use today to handle more than 10 million requests. Some of them go way above that with similar type of infrastructures. Another pattern that is very, very important that allows you to scale your application is, of course, event-driven. This is where you've probably heard about serverless. This is very important because basically it takes the infrastructure burden out of you. So you can, and event-driven is really the way we live and talk to each other, right? So using Lambda, for example, to process information and how, as it comes into the cloud, allows you to scale your infrastructure and react even faster. A very simple use case that is used very, very widely at Amazon is this use case that people put images into an S3 bucket, and that's an event that triggers Lambda to resize and do a lot of stuff on those images, thumbnailing, or do artificial intelligence detection on the images, all this kind of stuff. This is used widely by all the media companies, of course. I'm sorry for the alarm up there. Well, whoops. Big topic. I'm not going to go into the NoSQL versus SQL debate. I think you probably have heard that debate a lot. What I'm saying is use what is important to you to use. And the only way for you to know what's important is, and I give you that example, is understand what's happening in your environment. So in 2009, we had massive amount of Oracle database in our environment supporting Amazon.com, and we had big problem of scaling. So we started to scan what kind of queries we had, and we realized actually 70% of those queries had nothing relational in it. And this is how we all started working with DynamoDB, or at least built a system in Amazon to support these kind of queries. So instead of having a debate, verify what kind of queries you actually have. If you don't have transactional database, you don't have a debate. You know that it's NoSQL, right? All these kind of things. Transition state, as I talked, is for me was the single most problem that we had. Having counters or updates queries on SQL database basically was the single most problem to scaling. Removing those and putting those in actually specialized database was a a way to be safe. Another very important thing that people should do much earlier is sharding. Read-write sharding is one way, or doing some federation. It's all about basically doing what is good for your end user. And sharding, basing on region, where your customers are, is actually what is happening most of the time currently with big application that needs to scale. I'm sorry, I have a lot of content to talk about, but this is an image that I think also goes into the NoSQL, SQL debate. I don't use a Swiss Army knife to do everything. There's a lot of great databases out there to do what they're great at, whether you want to use Redis, Elasticsearch, MySQL, Postgres, Cassandra. They all have what their qualities, and so use those. Don't be stuck into your own ideas. And as a developer, we all have those preferences. Vim versus the rest of the world. It's the same with NoSQL and a database. Don't have that. It's about business. On that note, I'm going to show you just one number, what scaling looks like. These are the numbers of Amazon.com after they kind of implemented the kind of things I'm talking about. NoSQL database, we reached 12.9 million per second on one day. So this kind of scale that you can do, our API usage, 50 billion events in one day, right? This is Prime Day, it's the Black Friday of Amazon this summer. So they've done that, implementing basically some of the things we've done. So on that note, I would say happy scaling, and hopefully there's a couple of things that you got home, and I'll put all those slides online so you can access actually the text as well. Thank you very much.